Okay, so how's everything going? Assignment 10 is easy for those who've programmed in Java before. So it's, a lot of the questions look familiar from early assignments. That Java assignment is really just about getting you used to doing things that you should already know how to do, or most of the questions are things you should already know how to do in Python, but getting them done in Java. So last class we did a brief intro to some of the things that make Java different from Python. I want to delve into a little bit more of that today. In particular, the way you do object-oriented programming in Java versus Python. Or the way you do procedural programming in Java versus Python. So last class, basically, we just wrote this class that only had a main function. So let's take a look at different kinds of functions that you might have in Java. So let's create a class called tester. So this is a public class, meaning anybody can access it. And we saw that if you want to write any program that does anything in Java, you need a main function. And repeat this: public static void main string array args. Has to look exactly like that. Otherwise your class won't run. And this creates a function that'll run if you try and run that class. There's what we learned last class. And one of the first things we did in Python already in the first class, we were writing functions. It's just a really natural thing to do. You just define functions and use them. In Java, you can do the same thing. So for example, suppose I want to write a function which, computes the sum of the elements in some array. So how would I do that? Well, I need to, every time I write a function, I need to tell you what the return type is and what the arguments are for that function. So if I want to write a function that sums up the elements in an array, what are the arguments to that function? Yeah? An array. What kind of array? Not an array list, but an array of what? Yeah. So we have to decide now what kind of numbers are we going to add up with this thing. And I don't know, we can do an integer array. And we also have to decide what kind of thing this will return. And if we're summing up a bunch of integers, well, then the result is an integer. Seems like a natural thing to do. Although if we were expecting to really have to add up a lot of these things, maybe the result should be a long to make sure we don't run out of, we don't have to return something too big. But let's keep it at there for now. And we know how to write this thing now. Well, we could. It's not quite as easy as Python, but we know how to do this kind of thing with a while loop or a for loop. So let's use a for loop. So start with an accumulator s set to 0, and say for every integer x in A, s equals s plus x. And then we return s. I forgot to tell this thing what x was. It's an integer. Okay, so that compiles. Great. So we wrote this this thing that does this. Now, let's say we want to use this thing. All right. So let's say we want to print out the sum of this array A here. So how do we call this function? Yep. Something like this. So, who thinks that's going to work? You think that's going to work? Yeah? Let's try. And it tells you no. Non-static method sum cannot be referenced from a static context. And we didn't really need to specify tester here. By default, when you specify something that's, you just give a name, it'll look for it inside the class that's calling it. So we didn't need to say that it was part of tester. But we still get the same error. Non-static method cannot be referenced from a static context. Okay, so what does that mean? Well, tester is non-static, meaning it doesn't have that static keyword in front of it. So that means that tester is actually a function that's supposed to work on instances of the tester class, the way we've written it here. Now, for us, that doesn't really make sense because tester, all it cares, or this, sorry, not tester, sum, all it cares about is this array you pass it. It adds up all the stuff in the array and returns it. It doesn't need any other information than that. So that means tester should really be a static method. There's no object involved that you're applying, or sum should really be a static method rather. There's no object there that you're applying the sum to. There's just this array argument that you pass to it. So this is just like a function in Python that you would write right at the highest level of scope, not indented at all, not inside any class. Yeah.
So, like if we were using Java for our game, then in kind of like in our script that had in our event loop, in our actual game, it seems like
Yep.
most of our functions would be static, right?
Not really, because most of our functions in our, or at least in the game that I was writing, were inside some class. So there was, you know, the game class, which had a lot of attributes like the score and a list of all the missiles that are currently active and so on. So they would all be functions inside that class, and they would use those variables. So the game one is not a good example, but for most of the code we wrote before that, we were just writing functions. And so basically, if all you want to do is write functions and don't care about object-oriented programming, don't care about making classes, then you wrap everything in a class because everything has to be in a class in Java, but then you make everything static. So every function static. So now we can do this. And it's happy. And indeed, it correctly computes the sum of this array. So let's compare that to something different. So here's another class we've started, person. So this is a class that I really want to have represent a person. So for example, our persons are not usually very interesting, so they have something like a first name and a last name. And you want to be able to create a person. And so in Java, the way you do that is you define a function that has the same name as the class. So that's called a constructor. So we'll create a public function called person, and it'll take 2 string arguments, the first name and the last name. Okay, so our person class has 2 what they call instance variables. They're called properties in Python, but they're the same thing. First name and last name, each one of those is a string. And when we construct a new person, we're supposed to pass in the first name and the last name, and we save those in those variables. Okay. All right, good. And all right, so let's just see if that works. So how do we make one of these new persons? Just with something like this. We declare a person P and say this is a new person. First name Pat, last name Moore. Print the person. We can print their first name. We can print their last name. Okay, so here is us printing the person. It prints out in a funny way. It says it's a person, and similar to what Python does, it gives us some representation of where this person lives in memory. So P is really just a reference to this memory location. First name is Pat, last name is Moore. And when we create something new this way, using, create a new object using new, this is really like what happens when you create objects in Python. And assignment is the same, has the same kind of picture. So if I say person Q is equal to P, then what I'm really doing is saying that Q now refers to the same person as P. So if I do something like P dot first name equals James, and I print Q's first name, I'll get something like this. So by changing P's first name, I'm also changing Q's first name. It's that diagram we've seen before where there's one person object off in memory, and both P and Q are variables that refer to it. So every time you create an object in Java, it goes off in memory somewhere in a place called the heap. And all these variables that you declare, like here we declare this person Q, and we declare this person P, they are really just references to things that are often in memory, or they're set to null if they don't reference anything. All right. So one thing that is really frowned upon in Java is doing what I just did, which is accessing data inside of classes. So this is generally a no-no when I do something like, say, p.firstname, actually getting the person's first name. Usually you want to do that in some more controlled way. Same thing here when I got the first name and the last name. You usually would like to do that in a more controlled way. And so typical pattern is you write so-called getters and setters. So usual Java class, even for something as simple as this, will have some function called get first name, which will do nothing other than return the first name. And get last name, which will do nothing other than return the last name. And if you wanted to be able to change names, you'd also have okay, so this is the so-called setter for first name, the setter for last name. This is the getter for the last name, and the getter. So this is such a common pattern of coding in Java that many IDEs, when you declare something like this, when you say a person has a first name, you can often just right-click on that, and one of the options that comes up is to create getters and setters for this thing. It'll create those two functions that change the value and that set the get the value and set the value. So the more, the way Java programmers would like to see this kind of thing written is p dot get first name, p dot get last name, and same thing here, p dot set first name, and of course, forgot the return types. So get first name should return a string. Get last name should return a string. Set first name doesn't have to return anything. The shorthand for that is you say that its a return type is void. And the same thing with the set last name. It's really hard to go back and forth between programming in Java and programming in Python. When you go to Java, you start forgetting everything to include all these things. Yep?
How the tester file is accessing the person.java file?
How is it accessing it?
Yeah.
They're both in the same directory. That's all it needs. So technically, that means they're both in the same package. It's the global package, so the person is accessible inside the tester class. Yeah.
So if you want to encapsulate these variables, could you not click on?
Yes. So that's the next point. Is yes, you provide these getters and setters because you don't want people maybe necessarily accessing the first name and the last name directly. Why wouldn't you want that? Well, maybe you wouldn't want that because you're thinking that maybe later in life you may change the representation of the first name and last name. Maybe actually what will happen at some point in the future, you may not explicitly store these strings, but you might retrieve them from a database or change them inside a database. So you want them to use this get first name, get last name, and not take shortcuts and just access them directly. And for that, Java has all kinds of access modifiers. In this case, you could make them what's called private. So private means that no other class can access these variables, these instance variables of a person, well, they just can't access them. They're not accessible. If I try and access them directly now, as I was doing before, I'll get an error. So first name has private access, in person is the error that you get, and so it's telling me that I'm not allowed to access it. So private is somehow the most secure thing. Nobody's allowed to access it except for the person class itself. There's another level above that, which is a little bit less restrictive. It's called protected, which is it first name or last name? Protected allows a little more access. In fact, it's enough even for to allow this thing to access it. Tester is allowed to access first name now, but it's not allowed to access last name because I kept that private. So it's still not allowed to access last name. And protected means anybody in the same package. In this case, there's no package, it's just the global package. So anybody in this global package is allowed to access it. And tester and person are both in the same package, so tester's allowed. And then there's a third level. There's the highest level, which is public, which means anything, anywhere can access this thing. So we use that for these getters and setters. This is the method we want people to use to access it. Okay. So you can think of it sort of as private is really within the class. Protected is really anyone who is writing this part of the code can access it, but people outside of this work group who are writing this code shouldn't access it. In this case, we might as well keep them both private. Okay. So we'll flag these as errors, accessing private variables, not allowed. Okay. So the main thing is static. If you just want to write a function that doesn't require any objects to run. So for example, here we just called the sum function on an array. We didn't need any object. Whereas things like get first name and get last name, those only apply to an object. So you can't just get the first name of nothing. You can't say get first name unless you have a person whose first name you want to get. All right. One more little syntax piece. Here we kind of dodged it, but when we were writing this person class, we had this constructor that took a first name and a last name. Might be a little bit more meaningful if we made the arguments a bit longer, so we made the names of those two arguments a bit more easier to read. But then we have a problem, don't we? So then I would write something like this. Is that going to work? Somehow this doesn't look really useful, right? We set first name equal to first name, and we set last name equal to last name. So will that run? Let's find out. So now, when we print our person, we get that the first name is null and the last name is null. What happened? Yep.
You're not making it assigned to the values. All you did was just create first name, last name, private first name, private last name.
Yeah, so here I have an argument called first name, and here I do an assignment where I say, take that argument and set it equal to first name, which does nothing because it's already equal to first name. And I have an argument called last name, and here I set that argument last name equal to last name. Now what I really intended to do was not set the argument. What I intended to do is set this so-called instance variable. So these things are called instance variables. But the way Java resolves things is first it looks in the local function to see if there's any names that match. In this case, it finds them there. They're arguments. If it didn't find any names that matched, it would look inside the object, the calling class, to see if there's any instance variables that match. And indeed, it would find them again. And doesn't give you any warnings if it could find them in both locations. It just takes the first place that works. So if we want to specify that what we really want is those instance variables, you have this keyword here. So this is exactly the same thing that in Python we keep calling self. So in Python there's always this first argument to functions that are parts of objects called self. And every time we want to access a property of that object, we had to put self in front of it. In Java, well, the word changes. It's not self. It's called this. And it's optional. You don't have to include it. Java will just look for it. If it doesn't find it in the local, if it doesn't find a variable in the local scope, it'll look for an instance variable with that name. And similarly, you can have static class variables that behave in a similar way. That they'll get looked for if you're in a static function. So this is useful for resolve, telling it which of those variables called first name do you care about, not the argument, but rather this one up here. Okay. Any questions about that? Good. All right, so what else does Python have? Python has functions, which we now know the equivalent thing in Java is static methods inside a class. Python has these classes, which in Java are classes with non-static methods. What else do we have in Python? What's one of the first things we used? Yeah. Whoa. Yeah, we don't get those in Java, unfortunately. Not list comprehensions, but lists. That's something we have in Python. Have we seen the equivalent thing in Java? Yeah, we've seen something kind of a crappy version of that in Java with Java arrays, but Java arrays are not really like lists. For one thing, a Java array, when you create it, it has a specific size when you create it, and that size doesn't change. Python lists, we could append things to them, we could do all kinds of nice stuff with them. So what's the equivalent thing in Java? Well, there's a class called an ArrayList. So it lives in a package called java.util, and java.util is not normally accessible. You have to import individual parts of it if you want to access them. So if I want to use an array list, that's what I have to do. And remember, this is Java. You have to specify the types of everything. So if I want to create an array list, well, just like an array, I can't just say something like this, array list al equals new array list. So why is that not a good idea, or why is it going to complain about that? Yeah.
Because there's no size.
It doesn't care about the size. The size of an array list can grow or shrink. That's all handled by it. Yeah.
Won't you just specify what's going to be in the array list with like the small and then bigger?
Yeah, so Java likes to know the type of everything. So when I make something like an array list or any kind of container, it wants to know what I'm going to put in that container. And so, I don't know, we could make an array list of persons. And the way you specify that is with these greater than or less than signs. So you specify, this is an array list that's going to contain person objects. And then I can say something like, you can add elements to array lists, you can remove elements from array lists, you can do all kinds of things. So let's add a person to this, new person. Let's add another person. And then print that array list. So here's the array list being printed out. It prints it out in a fairly understandable way. It sort of shows it in these square brackets, and it says there's a person, and there's a person in there. So it does that. One thing that might be nice is to actually have the persons print themselves out nicely. How would we have done this in Python? If we wanted a class to print itself nicely, yeah?
You would have overwritten the
Yeah, well, in Python it's the underscore, underscore, str, underscore, underscore method. In Java it's the toString method. So if we go back to our person class, we can do public string, write a method called toString, which returns a string representation of this this person, which could be just we could do first name plus space plus last name. That's a decent string representation. And now when we do that, we get, when a person gets converted to a string, which is what happens when an array list prints out its contents, it takes each of its elements and converts it to a string. Now it actually does it it uses our method for converting it to a string, not the default method, which just prints the name of the class and the location. Okay. So here's an exercise for us then. Let's try and one of the most useful functions one of the most used functions anyway in Python is the range function. Let's try and write the same thing in Java. So if I want to write the range function, what would it return? And let's go with the simple version that takes only one argument. Yep.
It just returns all values between 0 and whatever.
Okay, so what kind of thing is that?
An array.
An array, so we could do an array or we could do an array list now. Both of those things hold stuff. Maybe an array list is easier to work with. So it's supposed to return an array list. And an array list of what? Of integers. Like this? It returns integers. Okay, so we're still trying to write this function definition. So an array list of integers. Any other modifiers we need here? Is this a public function? It's up to us. Might as well make it public so anybody can use it. Is it static or not? So if I want to create a range, do I need some object to call it on? So in Python, do we use range by saying something like x.range or y.range? We just call it, right? It's just a function returns a value. So that means it's going to be a static function. And it takes an argument n, and the type of that argument will be an integer. Okay, good. All right, what next?
The length?
What about the length?
How many elements?
Well, so the one argument version of range just gives you the integers 0, 1, 2, 3, 4, 5 up to the argument minus 1, so n minus 1. So how do we do that? What's that? For loop. For I equals 0, I is less than n, I plus plus. I will take on the value 0 all the way up to n minus 1, so as long as it's n minus 1, incrementing between each one. And then what? So what do we do with these values of I? So, like this. Yep. Yep, so we'll have to create an array list that's going to hold all these values of I. So, of course, we can't return I, otherwise we'll just return when I equals 0 immediately. So, to this array list, we'll just add the current value of I. And then by the time we're done, we can just return the array list. Yeah. Yeah. So there's a little cruftiness of Java that creeps up here. And that is that containers like ArrayList, and we'll see some other ones, set and map, they can't hold anything. You can't just put just anything in there. They can hold persons and they can hold other kinds of objects, but they can't hold these primitive types. So remember we saw there's all these primitive types, int, float, double, all of these things. You can't stick those into an array list. Let's see what happens when we try to. We get an error. It says error expected type, and then required a reference, but it found an int. So the type we asked it to store was int, but it's saying it can only accept references. So that means it can only accept none of these primitive types. We saw like 8 of them. None of those can be stored in an array list. Instead, we have to store objects of some kind. And so we need a way around that. And so Java has that built in. For every primitive type, there is a corresponding class that does exactly the same thing as that primitive type does, but it actually has it all wrapped up inside a class. So for int, Java has the integer class. That's great. Good job, Sun Microsystems. There we go. The Java integer class, which basically implements everything an int does, but as a class. So that's what we need to use. So instead of an int here, we store an integer. 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 And since Java 6 or 7 maybe, the conversion between int and integer just happens automatically. So notice here we have this variable I, which is actually an int, and we add it to this array list, which is expecting an integer, but the conversion just happens automatically. You don't see it happening, but there is a conversion happening there. Let's see if we got that. So that compiles fine, and we can test it. Okay, so there's the range. When we call range 10, we get this array list that contains 0 through 9. And of course now, with that, if we wanted to, although it's a bit silly, we can write for loops the same way we would in Python. So we'd say something like for integer I in range 12. So there you go. I don't recommend doing that because it's a lot of work to create an array just so that that contains 0 through n-1, just so that you can output the elements 0 through n-1. Use a regular, so this kind of for loop instead. But if you really love it, doing it that way, then you can. Okay, so anytime you create one of these collections, whether it's a collection of persons or integers or whatever, you have to specify what it holds at the time you create it, and you can't put in something that's not supposed to be there. So for example, in my array list of persons, or my, let's say, array list integer 2 equals range 10. So this creates an array list of integers, and if I try and add a person to it, it just says, it gives me a very long-winded error. Tells me there's no suitable method found for add person. So it's a long-winded error, but it's basically saying that it looked inside the ArrayList class, the ArrayList integer class, at all the methods called add. There's a bunch of them. And none of them seem to work with the kind of argument that I've given it. So I've given it a person, and it says, well, there's one called add with that takes 2 arguments, an int and an integer. There's one that takes just an integer, and then there's a few other ones that take ints and integers, but none of them take persons. So it just says I can't do this for you. So this generates generates that kind of error. So again, everything's really quite strict about the kinds of things that it holds. Okay, what can you do with these array lists? Let's play around with them a bit. They're quite useful. I mean, as useful as lists in Python, and so it's good to know the kinds of things you can do. Of course, you can print them. We saw that you can add things to them. So the add method, if you call it with just one argument, it adds things to the end. But you can also add things in other places. So for example, I can add an element at position 0, and let's put a -1 there. And now if I print this thing out, it really takes this new element that I'm adding, which is -1, and puts it in the list so that its list index is 0. So it becomes the first element of the list. And I could have done that for any index I wanted, so I could have put it at index 5, for example. And then it shows up at index 5, right? 0, 1, 2, 3, 4, 5. And of course, the other stuff, the stuff at index 5 and onwards gets pushed down by this, so their indices increase. So not only can you append to one of these things, but you can insert anywhere. You can remove elements. So let's remove the item at position 6. So removing the item at position 6 is going to remove which number from this list? -1, 6. Let's count it. 0, 1, 2, 3, 4, 5, 6. So it's number 5. And that's because when we inserted -1 at position 5, well, that means the thing that used to be at position 5 is now at position 6. So this is, those two operations effectively overwrite 5 with -1. Now, if that's what you're trying to do is just overwrite a number with another one, don't do it by adding and removing. Instead, there's a method for that. There's a set method. So we could set the element at position 7 to be, let's say, -2. Oops, we forgot to print it. So here we set the element at position 7 equal to -2. By the time we get to there, the element at position 7 is actually 7, and we just change its value to -2. That's a lot more efficient than inserting something and removing. And of course, we can get any value. The element at index 3, or let's say index 5. So the element at position 5 is indeed -1. So you can get values, set values, add values to the end, and add or remove values from anywhere. If you care about performance and you're working with big array lists, then don't be adding or removing values anywhere except at the end of the list. So every time you add or remove from the front, basically there's a whole bunch of data that has to move around in memory. So really the end is where you want to be adding and removing if performance is an issue for you. Okay. Other handy things to know about are stuff that in Python we have things like lists can be sorted in Python. In fact, we have two ways of doing that. We can take the list and call its sort method. So if we have a list L, we can say L.sort, and suddenly it's sorted. Or we can call the sorted function, which gives us a sorted version of the list. So it doesn't affect the original list. It gives us a new one that has all the same elements, but in sorted order. Or we can, well, so that there's sorted. But there's other things as well. We can shuffle a list randomly. We have that kind of stuff. Most of those things exist also in Java. What you need to look for, what you need to know is where to look for those things. And they are in Java collections class. So let's say I want to Okay. So let's say I want to sort a list. No, I don't need that. I need So let's say I want to sort a list. Where are you? There. There's a method called sort that takes a list as an argument and sorts it. So we can try and do that. It has a very complicated type signature. So it's hard to tell from read this to tell what it really returns. It doesn't return anything. The important word is void here. What it does is it sorts the list internally. And it's a static method. So how do we call static methods? So do I just say, let's say I want to sort this thing. I just say sort AL2. We can try. Nope, says it can't find the symbol sort. So how do we point it to this? How do we tell it to use this sorting method? We know it's somewhere in Java. Here it is there. What's that? Interestingly, we can't really import methods. We can only import classes. So let's see what class we'd have to import. It is the collections class in java.util. So let's import that. So we'll import java.util.collections. Be careful, there's also a class called collection. It's not the same thing. Is that going to be enough? Yeah. So it's not enough just to import the collections class. We now have to tell this thing that what we want is the sort method that's inside the collections class. And if we do that, then indeed we sort this thing and it comes out in sorted order in the way that's most natural for the elements that are stored in that class. Now, let's remember we have this array list of persons up here. Let's try and sort that. So, do you think that that's going to work? Maybe? No, won't even compile. We get an extremely long-winded error message, really tough to read. Inferred type does not conform to declared bounds. Holy smokes, what does that mean? Well, let's think about what it could mean. Why would it be difficult to sort these persons? Yeah? Yeah. What does it mean for one person to be less than another person? We didn't define that, and there's no sort of natural interpretation. So it's telling us we never define what that means, and therefore it can't deal with that. So it turns out if you want to define what it means for, one person to be greater than another, you have to do two things. One is you define a function called compare2. That tells you which one is smaller. So I want to compare this person to that person. And I don't know, maybe a natural thing is to just compare their last names. And so for that, I can just say return last name dot compare to that dot last name. So take my last name, if I want to be specific, this object's last name, and compare it to that object's last name. Okay? So you have to define this compare2 function. But that's still not quite enough. You need to tell Java that now that I've defined this, these things are ready, these persons are things that are comparable. And for that, you tell it that it implements I think this is the right way to do it. Yeah. So now it's happy, and indeed it sorts them by their last names. You could do something fancier if you wanted, but this works. Okay. All right. So if you want to use sorting on your own kind of objects, you have to tell Java that these objects are comparable. You do that by telling them that this class implements the comparable interface, and the comparable. If you implement the comparable interface, that means you have to define a function called compare2. Okay, what other things does, so other things offered in collections is, so you can sort using collections, you can shuffle, so that does a random shuffle. You can sort again, and you can reverse. Yeah, so here we are sorted, shuffled, sorted again, and then reversed, changing the order, making it backwards. And you can browse around in collections if there's some particular operation you want to do. You can grab things like sublists and so on. So that's all in there. One thing to be careful of, or one thing that's available with lists, is a so-called sublist method. So let's take our AL2. So remember in Python we had slices. We could take slices of a list, starting at some position and ending at some position. Well, we have the same thing available here. You call the list sublist method. And so here I'm asking for a slice that starts at index 3 and goes all the way up to, but not including index 7. So 3, 4, 5, and 6. Says it doesn't know about lists. So starting at position 3 is this thing, 4, 5, 6, and 7. So there's the slice that I get. Something to look out for, though, is these are different from Python slices in that they're not copies of the sublist. They're actually just references to the same list. So if I say list2 dot set 100, so that's going to take this sublist here, that's list 2, that contains 4, 3, 2, and 1. It's going to set the element at position 1 equal to 100. So the 3 is going to become 100. But that could have an unintended side effect. So indeed, it does set 3 equal to 100. But then if we go back and look at the list where we made this thing from, the list AL2, it's also had one of its elements set to 100. So when you take a sublist like this, it's not like in Python where it actually copies a whole part of the list. All it does is refer to that list and say, just focus on this part. Mostly you can't tell the difference until you start changing things, because then they start changing in both lists. So if I were to change AL2, then list 2 would change, and if I change list 2, then AL2 changes. So the picture of that is really something like this. We have AL2 refers to this list in memory, and we have list 2 actually refers to another thing, which refers to this part of the list right there. So when I start changing things in list 2, I'm actually changing the same locations. Advantage of that is getting a sublist is really fast. It doesn't matter how big the sublist is, you just specify the bounds and this thing gets created as fast as you want, because it doesn't have to copy anything. The disadvantage, of course, is that these two lists are now sharing the same data. That could lead to errors if you don't understand what's happening. But in the collections class, there is a copy method if what you really want is a copy of a sublist. Okay, good. what else do we have in Java? We have two big things that are useful in Python were sets and dictionaries. Both of those exist in Java. Let's take a look at sets. So again, Java has a class called hash set, and it also has a class called a hash map. So let me write these down with some comments. This is like Python's list. This is just some utilities. Hash set is like Python's set, and hash map is like Python's dictionaries. So use these the same way. So hash set of integers is equal to a new hash set of integers, and let's call this thing HS. And so here, this last line is printing out our hash set that contains those four values that I added, 5, 4, 99, and 52. And they're printed in some arbitrary order, again, because this thing represents a mathematical set. The order that we put them in has maybe nothing to do with the order that they're stored or the order that they'll come out of this thing. You can use for loops on these things, just like you can on ArrayLists or arrays. So I can say for integer x in HS, print x. Nope, not that easy. So you can iterate over them, and the elements get iterated over in whatever order happens to be convenient for this thing. You can remove things from sets, so I can try and remove 99, for example. And then I get a set that does not include 99. And the other main operation, the one that sets are useful for, is so if in that set I ask if it contains 88, then the answer is false. And if I ask if it contains 4, the answer is true. So remember, those are the three things that you mainly do with sets. You add things, you remove things, and you check if some value is contained there. Yep. No duplicates allowed in a set. So it conforms to the mathematical definition, which is unordered collection of distinct elements, the keyword being distinct. So, right, I can try and add 52 again. but still 52 only appears once in the set. So the add method fails. In fact, it returns false if it's unable to add it, if it's already there. Okay, and now there is the equivalent of dictionaries, Python's dictionaries, which are implemented by Java's maps. So, or hash maps rather. So there we're creating, looks like we're creating a new hash map. Looks a bit too simple. What's missing?
Type of key and type of thing or some key.
Yeah, so dictionaries are different than all these other collections like array lists and sets because there's actually two types involved. There's the type of things which form the keys, so the words in the dictionary, and then there's the type of things which form the definitions, the values in the dictionary. So when you specify one of these things, you actually have to specify two of them. So let's say I want a dictionary that has integer keys and person values. And now you can add things to these, and it looks like this. Excuse me. Okay. Missing parentheses. So again, you create this thing called a hash map, which is like a Python dictionary. If you print it, you get some nice printout that says, for this key, 437229, there's the value John Smith. For 983722, there's Eric Beale. And for 201273, there's Pat Morin. And of course, the main point of these is not to print them, but to be able to quickly look up values given their key. So if I get 201273, it should extract the person. Excuse me. Yeah. So there's put for setting a value for a key, and there's get. What you have to be careful of is not to try and get a value that's not there. So if you're not certain that a value is there, you first need to check if the key is in there before you try and look it up. So think it's called contains key. So in that dictionary, I can ask it if does it contain this key 999999. That returns true. Indeed, there's no such key, but it does contain the key. Returns false rather, but it does contain the key 983722. So often you'll have an if statement that checks if it contains the key, and if so, it then gets it. And of course, there's lots more in all of these classes, but you can look up this stuff in the documentation. Now that you know that they exist and what their names are, you can dig them up. And so now, congratulations to all of you. You're Java programmers now. So we'll start off again next week, going back and looking at more interesting topics that are not about language syntax, but algorithms, recursion, problem solving stuff.
You already kind of touched up on what I was going to ask at the beginning. Like I was going to ask for question 5, am I allowed to